we have to do? I have already told you in transportation problem what we have to do. We have to find out the optimal solution. For that, our first step is to find out the initial basic physical solution. Then to find out the whether your given initial basic physical solution is optimal or not. To find out the initial basic physical solution, we use what we have. I'm telling you about the two methods only. Your first method is northwest corner method, and your second method is Google's approximation method. I have already given you a problem where I have solved your problem and find out the initial basic physical solution by northwest corner method. Now I have taken a problem where I am finding out the initial basic physical solution by Google's approximation method. Now, what I have told you, your first step in the Google's approximation method is find out the difference of minimum and next to minimum per unit cost in each row and each column. Now, these are the penalties, we also call them penalties. Difference of minimum cost per unit cost and next to minimum cost. Now, our next step in the Google's approximation method is we'll find out the maximum penalty, maximum difference of minimum per unit cost and next to minimum per unit cost. So next your maximum difference is 10. What we'll do, we'll encircle this. Now this is corresponding to your fourth destination. This is corresponding to your fourth destination. What we'll do? We'll find out the minimum per unit cost in this column. Minimum per unit cost in this column is 13. It is 13. So what we'll do? We'll allocate your units minimum of 11 and 15 here. So what we'll do? We'll allocate 11 units here. So your availability at source 1 is exhausted, and at the destination 4, your requirement left is 4. Now, in the next calculation, what we'll do? While calculating again your penalties, what we'll do? We'll eliminate the column or row where your availability or requirement is exhausted. So we can see that this row has to be eliminated when you go for next calculation. So we'll eliminate this row. Again, by eliminating this row, we'll find out your penalties for rest of the rows and columns. Okay, this is minimum and next to minimum. This is 3. Minimum and next to minimum, again 9. Here, minimum and next to minimum, it is what? 18. Minimum next to minimum 4. Minimum next to minimum 9. Minimum next to minimum 15. Again, what we'll do? We'll find out the maximum penalty. This is 18. So we'll again encircle this and find out the minimum per unit cost in this column again. This is your minimum per unit cost. We'll allocate minimum of 13 and 4 here. So your requirement for fourth destination is complete, and the availability left here is 9. So for the next calculation, what we will do? We'll eliminate this column. Again, we'll calculate the penalties. Again, minimum and next to minimum. This is 3. Minimum next to minimum 9. Minimum next to minimum 4. minimum, next to minimum 9, minimum, next to minimum 15. Now we can see that your maximum penalty is maximum penalty is 15. We'll encircle this and find out the minimum per unit cost in this column, that is 17, and we'll allocate minimum of 6 and 9, that is 6 units here, and this your requirement for first destination is complete, and we are left with 3 units here. In the next calculation, we'll eliminate this column. Again, we'll find out the penalty. This is 4. Again 9. Again 4. Again 9. So we can see that there is a tie. When there is a tie, you can choose either of the penalties. You can choose either of the penalties, and if we take this, if we encircle this, so minimum cost is 18. Minimum per cost is 18, so we'll allocate 12 here, and your requirement for destination 3 is complete. We are left with how many units here? 7 units here, and in the next calculation, this column is eliminated, and now we are left with only single column where the requirement is 10 and the availability is 3 and 7. So what we'll do, we'll allocate 3 units here and we'll allocate 7 units here. So your requirement of all the destination is complete and your availability at all the 3 sources is complete. And this is your initial basic feasible solution. Initial basic, so how many cells are there for basic feasible solution? 1, 2, 3, 4, 5, 6. M plus n minus 1. So there is no need to add any other cell. So this is your initial basic feasible solution which we have found with the help of Google's approximation method. Our next step is whether this initial basic feasible solution is optimal or not. It is optimal or not means whether this will give me the minimum cost of transportation or not. For that, I'll again explain you how do we find out whether the given initial basic feasible solution is optimal or not. Basically, what we'll do, we'll again form our table of transportation problem and its solution. So again, with allocation, 1, 2, 3 are the sources. 1, 2, 3 and 4, they are destinations. B1, B2, B3, B4. Again, per unit cost given to us was 21, 16, 25, 13, 17, 18, 14, 23, 32, 27, 18, 41, So, and my allocation by Vogel's approximation method is 11, 6, 3, 4, 7, and 12. Now this is my initial basic feasible solution, and see that my basic feasible solution is what? This is the amount to be transported from first destination to first source to fourth destination. So x1 4 is 11. Again, this is 6 units are to be transported from second source to first destination. This is x21 is 6. Similarly, x22 is 3. Again, x32 is 7 and x33 is 12. One left, x24 is also there. X24 is 4. So we can see that total number of basic cells are 6. M plus n minus 1 is 6. Now, my purpose is what I'll do. These are the amounts to be transported from these three sources to various destinations, and where your amount available at various sources is exhausted and the requirement of the four destinations is also complete. First, what I'll do, I'll find out the cost of transportation here. How I'll find out the cost? This is your amount to be transported, this is per unit cost. What I'll do, total cost when we have an initial basic feasible solution, this is 11 multiplied by 13 plus 6 multiplied by 17 plus 3 multiplied by 18 plus 4 multiplied by 23 plus 7 multiplied by 27 plus 12 multiplied by 18. This will give me the total cost when we have a initial basic feasible solution. ये बताइए मुझे कैलकुलेटर की कितनी कॉस्ट आ रही है? कैलकुलेटर में कैलकुलेटर बताओ मेरे पास
796.
796 आ रही है 796. So this is the cost of transporting your material from your three destinations for three sources to four destinations where the requirement and is met at the four destinations. Now the total cost is 796. Now we have to see whether this solution, initial basic physical solution which we have found by Vogel's approximation method is an optimal solution or not. Or we get some other solution which will give me the cost less than 796. For that, what we do? We use to check the optimality of this initial basic physical solution, we use Modi method. What we do? We call it modified simplex method. In short, we call it Modi method. In short, what we call? We call it Modi method. For that, what we do? We find out your three variables corresponding to your sources and corresponding to your destination, we call them VJs. Now, how to calculate this UIs and VJs? How to calculate these UIs and VJs? For that, what we do, we arbitrarily put one of the UIs and VJ equal to 0. One of the UIs and VJ equal to 0. Suppose this is my U2. Suppose I put it equal to, and by putting one of the variables UIs and VJs equal to 0, we find out rest of the variables. We find out rest of the variables. How do we find out rest of the variables? As I have already told you that these are the basic cells of the solution where the allocation is there, those are known as the basic cells. To find out rest of the variables, what we do, we use the equation for basic cells ui plus vj is equal to cij. Ui plus vj is equal to cij. Means that by using this equation, we find out rest of the variables. Now we have already taken arbitrarily u2 equal to 0. So it means what? For basic cells, ui plus vj, it means that this plus this should be equal to this. This plus this, your v4, u2 plus v4 should be equal to c24. Should be equal to c24. So it will be basically 23. Again, this is next basic cell. This your u2 plus v2 should be equal to c22. So it will be 18. Simple calculation. Again, your c2 u2 we have already taken as 0. This plus v1. This plus v1 should be equal to c21. u2 plus v1 should be equal to c21. So 0 plus 32. Sorry. 0 plus 17 is equal to 17. Now we have calculated these three variables. Again, for basic cells, we can see that this is a basic cell where we have v2 is equal to 18. So your u3 plus v2 is equal to c32. c32. So this will be 9. Again, this plus this should be equal to this. This is again 9. This plus this should be equal to this is again basic cell. So this is your minus. So by arbitrarily taking one of the UIs and VJs equal to 0, we have calculated rest of the UIs and VJs, and for that we have used the equation UI plus VJ is equal to CI. Now to check the optimality, what we'll do, we'll again find out for non-basic cells. For non-basic cells, as per Modi method, calculate ui plus vj minus ci. For non-basic cell, as per Modi method, calculate your ui plus vj minus cij. If for all non-basic cells, for non-basic cells, means where there is no allocation. If all ui plus vj minus cij are less than equal to 0 for non-basic cells, then initial basic feasible solution is optimal. So for the body method, what we do, if for all non-basic cells, Ui plus Bj minus Cij, they are less than 0, it means that the given initial basic feasible solution which we have found with the help of Vogel's approximation method is the optimal solution. Now let us calculate Ui plus Bj minus Cij for non-basic cells. Now we can see that minus 10 plus 17, 7 minus 21. It means that this is negative. Again, minus 10 plus 18, minus 10 plus 18, minus 8. This is again negative. Again, minus 10 plus 9 minus 8, this is negative. Again, this 0 plus 9 minus 14 is negative. This plus this minus 41 is negative. And 9 plus 17 minus 32 is. So, when we have calculated Ui plus Vj minus Cij for the non-basic cell as per Modi method, and we can see here that the initial basic feasible solution which we have found by Vogel's approximation method, and when we have applied Modi method to check its optimality, we can see that the initial basic feasible solution which we have found by Vogel's approximation method is optimal solution as per Modi method. Modi method means modified simplex method. Modified. So there is no other solution. There is no other solution which will lower the cost than 796, which was the total cost of transporting the given material required, the given material to the destination as per their requirement. So this is a basic of transportation problem where what we do, transportation problem deals with the how deals with finding out the cost of transportation from end sources to end destination, and our purpose is basically to minimize the cost of transportation, and the material available at end sources has to be transported to end destination, and the material available at end sources should be equal to your material to be transported to end destination as per their requirement, and this is your first condition. And after verifying this condition, what we do, we find out a initial basic feasible solution. So given transportation problem, either by northwest corner method or Google's approximation method, I have already told you, until unless it is given to you, we always find out the initial basic feasible solution by Google's approximation method, and after finding out the initial solution by Google's approximation method, what we do, we check its optimality, whether the given initial basic feasible solution is optimal or not. So for that we use Modi method, we also call it modified simplex method, and by putting different conditions as per Modi method, we can check the optimality of the given initial basic feasible solution. The problem which I have taken here and I have found your initial basic feasible solution by Google's approximation method is the optimal method when we have applied your Modi method. There are other problems also where we apply, whenever we apply your any method to find out your initial basic feasible solution, and if we check its optimality, then that is not the optimal one. For that, again, we have to proceed further as per Modi method, where we form groups and we go to next. Today, let us close here, and next time I take this